So today it's called the multiplication rule, and I'm sorry you can't see that. You're always welcome to write it at the top of your paper. So today we're doing the multiplication rule. You use this rule when the question is a and question. So yesterday we said, what's the probability of rolling doubles and a sum of 8? Okay, so that's when you would use the multiplication rule. In probability, and is the upside down U. Okay, remember I told you yesterday I thought that looked like an N is how I remember it. So that's the notation for and. And it's the probability of A times the probability of B given A. Okay, so to find out if A and B has happened, you take the probability that A times it by the probability of B, assuming this means given, which means you're assuming A has already happened. Okay, so let's do a problem and it'll make more sense. Suppose a hat contains 5 red and 3 blue tickets. One ticket is randomly chosen, its color is noted, and it's put aside. A second ticket is randomly selected. What is the chance that it is red? Okay? All right, so if I want to know, I want the probability that the first one is red and what? And the second is red. Okay, so another way to rewrite that question, I want the probability of the first one being red and the second one being red. So this is an and question, so I'm using the multiply rule. Okay? So what's the probability that the first one is red? Well, how many red tickets are there? 5. Out of how many? 8. Okay? Then I am multiplying. Now be careful here. I want the second ticket to be red too, right? Okay? But what did it say happened to the first ticket? They put it aside. Now how many red tickets are left in the hat? 4. There's only 4 red tickets left. So that's what this means right here. You have to assume the first thing happened. That's what that line means. You're assuming the first thing happened. So we assume we drew a red, so now there's only 4 red left. How many tickets are left in the whole bag? 7. Very good. Okay, and that's how you get your answer. So 5/8 times 4/7. Don't forget your parentheses when you're putting fractions in. 5/8 times 4/7. And so you could put 0.357, or you could put 5/14. Okay. You know, I like fractions best, but either one is technically correct. Okay. All right. Now let's do this. If the first ticket was blue, what's the probability the second is red? Okay, so this time I want blue first and then a red. So this, I know I'm not writing it all out, but this means the probability that the first one's blue and the second is red. Okay, so if you use your rule, what's the probability of getting a blue? 3 tickets. There's 3 blue tickets out of 8, and then we're multiplying. The probability of getting a red, how many red tickets are in there? There's still 5 red. But how many total tickets are in the bag now? 7. Just 7. Okay. So 3/8 times 5/7. 15/56. Okay. All right, questions on that? All right, Rob and Carrie each roll a die. Determine the probability that Rob rolls a 4 and Carrie rolls a 2. Okay? All right, what's the probability that Rob rolls a 4? So 1 out of 6. If you think about a die, there's how many sides? 6. And how many show a 4? 1. That's where we got 1 out of 6 from. Okay? Then we are multiplying, because this means and is multiply. Now think about this. Does it matter that Rob rolled a 4? Will it affect what Carrie rolls? No. So Carrie to roll a 2, what's that chance of that? 1 out of 6. Okay. So the second fraction doesn't always change. It depends on the situation. Okay. 1/6 times 1/6 is 1 out of 36. Okay. Questions? All right, Rob rolls an odd number and Carrie rolls a number greater than 4. All right, how many odd numbers are there on a dice? 3. 1, 3, and 5. So 3 out of 6. And then we're multiplying. Carrie rolls a number greater than 4. What are the numbers on a dice that are greater than 4? 5 and 6. So there's 2 out of 6. Okay? And you're multiplying those, which gives you what? Should be 1 6. All right, they both roll a number greater than 1. So let's talk about Rob first. How many ways can he roll a number greater than 1? 5 out of 6. And then what about Carrie? 5 out of 6. Okay. Which gives you 25 over 36, which I don't think reduces. But correct me if I'm wrong. Okay. All right, example 3. A school has 2 photocopiers on any given day. Copier A has an 8% chance of malfunctioning, and machine B has a 12% chance of malfunctioning. Determine the probability on any given day both machines will malfunction. Okay? So I want the probability that A will malfunction and B will malfunction. So I'm just trying to write it using this symbol. Okay, so A will malfunction and B will malfunction. Okay? So since it's an and, I'm going to be multiplying. What's the probability that A malfunctions? 8%. So you need to write that as 0.08. Okay? 0.08, and remember, and means to multiply. What's the probability that B will malfunction? 12%. How do you write 12%? 0.12. All right, so 0.08 times 0.12, 0.0096. What would that be if you converted it back to a percent?
86%. I mean 9%.
How many times do you move a decimal? Twice. You move it twice, so it would be what? 0.96. Okay? All right. We want both of them, again, they used the word both right there. We want both of them to work effectively now. Okay? What's the chance that copier A will work effectively?
92%.
Ah, very good. If it has an 8% chance of malfunctioning, you do 100 minus 8, because 100 is the most percent, okay, is the total percent. 100 minus 8 gives you 92%, so 0.92. So that's for A. B had a 12% chance of malfunctioning, so what's the chance that it will work? 0.88. Okay. And so we get what?
0.89.
Right. Questions? All right. A box has 3 red, 2 blue, and 1 yellow marbles, it should say. If we draw 2 marbles out, what is the probability of getting 2 red marbles if replacement occurs? What does it mean by replacement occurs? What does that mean, if replacement occurs? If you put it back, okay? So 2 red marbles. So I want a red and a red. Okay, a red and red. What's the probability of the first one being red? Good. So 3 reds out of 6, which is 1/2. You're welcome to write 1/2. That's great, okay? All right, then we're multiplying. The second one being red, I have put it back. It says replacement occurred, so I put it back. So what's the probability the second one is red? 3 out of 6. All 3 red ones are back in, and so you still have a total of 6. All right, 1/2 times 1/2 is 1/4. Okay. All right. 2 blue marbles if replacement occurs. So I want a blue and a blue. All right, what's the probability for the first one being blue? 2 out of 6. What about the second one? 2 out of 6. Because I put the first one back. So there's still a 2 out of 6 chance. So that's 1/3 times 1/3, which is 1/9. Okay. All right. 2 red marbles if replacement does not occur. Okay. So I want a red and a red. All right, what's the probability of the first one being red? 3 out of 6 for red. Okay, now, you did not replace it, so how many reds are left? 2 out of 5. Okay, there's only 5 left in the bag. So that is what, 1/5, I think? Okay. All right, 2 blue if replacement does not occur. All right, so I want a blue and a blue. What's the probability of the first one being blue? 2 out of 6. What about the second one? 1 out of 5. There's only 1 blue one left. So that is 1/15, I think. Okay. Questions? All right. A hat contains 9 names of players in a tennis squad, including the captain and vice captain. If a team of 3 is chosen at random by drawing the names from the hat, determine the probability that it does not contain the captain. Okay? So let's talk about drawing the first name out. How many names are in the bag?
7.
All right, so I'm going to find my bottom number first, my denominator. So there's 7 names in the hat. I want it to not contain the captain. So how many choices would not contain the captain?
Just the captain, not the vice captain?
6. Okay, there's 6 that would not contain the captain. Okay? Now I'm getting ready to choose another name. What would my next fraction be? 5/6. Because look, I am 3 are chosen at random by drawing the names out of the hat. So I'm not putting them back because I'm trying to come up with 3 names. Okay, so 5 out of 6. All right, and then 4/5. Okay, so you would multiply those all together because you drew 3 names out of a hat. Thank you. 4/7. Okay. All right, this time I want it to not contain the captain or the vice captain. So how many names are in the hat? 7. How many choices would I have that aren't the captain or the vice captain? Is that what they're calling them? 5. Okay. All right, somebody who hasn't answered today, what would my next fraction be? So how many names did I draw out here?
2.
Okay, so this is where it gets, you just got to think about it. This fraction represents drawing out 1 name. Now I have a 5 out of 7 chance of it not containing the captain or vice captain, but this represents pulling 1 name out of the hat, okay? So how many names are left in the hat that wouldn't be the captain or vice captain? 4 out of 6, okay? This fraction represents pulling the second name, okay? And then what about pulling the third name? What would the fraction be? 3 out of 5. Okay. All right, what do you get for this one? What is it? 2/7. Can somebody confirm that? Okay. All right. You have a deck of cards and you're going to pull 3 cards from the deck, replacing them each time. So that's important. You're replacing them each time. I'd underline that. I know it's hard to see up here, but I'd underline replacing them. Bless you. What is the probability you pull 3 face cards? If you're not familiar with cards, we'll do more of that on Monday. So for now, just kind of roll with this. Anybody know how many cards are in a deck?
52.
52. Okay. All right. So you're pulling 3 cards. Remember, you're doing it one at a time. Okay. You're pulling 3 cards, but you're pulling them one at a time. And I want them to be face cards. A face card is a king, jack, queen, or king. Okay? So there's 3 of those for hearts, 3 for spades, 3 for diamonds, and clubs. So that's a total of 12. Okay? So there's 12 face cards out of 52. So this represents pulling 1 card, and I'm pulling a total of 3. That means I'm going to have 3 fractions, okay? What's my next fraction going to be? What did this say? They're replacing them. It's 12 over 52. I replaced it. So there's still 12 face cards out of 52 in the deck. Okay? What about the third one? 12 over 52. It stays the same. Okay? What's a shortcut for putting that in your calculator? 12 over 52 to the third power. Okay? You get 27 over 2,197. Okay? All right. You pull 3 aces, so there's a total of 52. How many aces are there in the deck? 4. Okay? And I am replacing them, so the fraction would be the same, so you could do that to the third power. And math, enter 1 over 2,197. Okay. Okay, and you pull no face cards. How many face cards do we say there were? 12. So I'm going to do 52 minus 12. What's 52 minus 12? What is it? Okay, over 52. And again, I know that's going to be to the third power because I'm looking for no face card every time, and I'm replacing them. And so you get... Yep, 1,000 over 2,197.